Okay, with quadratics we have three forms: vertex form, which you already know, standard form, which you already know, and factored form, which you know as well. So we're just going to be using those to find different parts to the parabola. The first question, to find the x-intercepts from factored form, what you need to do is set each parentheses equal to 0 and solve. You're finding the zeros or the solutions at the same time. These are also the x-intercepts to the graph. So I have x equals -2 or +5/2. Here I'm asking the question, does every parabola have x-intercepts? And the answer is no. You have three options with x-intercepts. You could have a parabola that, if it's above the x-axis and is going up, opening up, it's not going to have any x-intercepts. At the same time, if it's below the x-axis and it's opening down, it's not going to have any x-intercepts. So either one of those options is possible. The majority of the time, you do have two x-intercepts. But there is a possibility if the vertex is on the x-axis, there is one x-intercept. So here I'm asking, how many x-intercepts do these functions have? And what you want to look at is the shifting in the y direction. So this one's shifted up, and you're looking at the a. Since the a is positive, then it's shifted above the x-intercept and it's opening up, which means that it's not going to have any x-intercepts. Where this one's shifted below the x-axis and it's opening up, which means it will cross the x-axis, so it's going to have two x-intercepts. Try to write a function with one x-intercept. Okay, and what you're going to do, basically you could have anything any function that doesn't have a k. The a could be positive, it could be negative, it could be shifted left or right, however many, as long as it's not shifted up or down. It will have one x-intercept. So to find the x-intercepts, what we do is we plug 0 in for y. And now I'm going to have to solve. So I'm going to add 2 to both sides. And then I'm going to have to take the square root of both sides. And remember, when you take the square root, because this is the same one that we went over before, if you don't include the plus or minus, you're only going to find one of the x-intercepts, not both of them. And then add 3 and write the decimal rounded to the nearest hundredth. So I have 3 plus square root of 2 which is equal to 4.41, and then I also have 3 minus the square root of 2, which is equivalent to 1.59. So my x-intercepts are 4.410 and 1.590. Okay, so here I'm going to try to write all three forms of this polynomial. And first I'm going to write it in vertex form. My A is a 1. So I have f of x equals x, and since it was shifted left 1, this is going to be plus 1 squared, and it was shifted down 4, so minus 4. To write that in standard form, I'm going to simplify it, so I have to do x plus 1 squared and then subtract 4. X plus 1 squared is going to be x squared plus 2x plus 1, so that's going to become x squared plus 2x minus 3. And then for factored form, I factor it, and because the a is 1 here, what multiplies to be negative 3, that adds to be positive 2, is positive 3 and negative 1. So these are the three forms of the quadratic. Okay, and here I'm giving it in standard form, and I need to write it in vertex form. So what I'm going to do is I'm going to group the first two. And I'm doing this by completing the square. So I'm going to make this into a perfect square trinomial. So what I'm trying to figure out is what constant can I add to that to make it a perfect square trinomial. And to do that, I'm going to take the b, divide it by 2, and square it. So 6 divided by 2 is 3. Squared becomes 9. I can't just add 9 to this quadratic though. So if I'm going to add 9, I also need to add a negative 9 in order to make it really all I'm adding a positive 9 and a negative 9, so it's really just like adding 0. But all I want in the parentheses is going to be the positive 9, so I'm going to bring this 9 on the outside, and now I can simplify it. Factor this, it's a perfect square trinomial now, so it's going to be x minus 3 squared. Negative 9 plus 4 becomes negative 5. These are the same directions here, but it's going to be a little bit more difficult because I have this coefficient here. And what I'm going to do is factor out a negative 3, and that's going to make this x squared plus, minus, because I factored out the negative, minus 2x. Now I only factored out of those first two. I want to keep the x there because I'm trying to make that into a perfect square trinomial. So when I do b over 2 squared, 2 divided by 2 is 1. 1 squared becomes 1. So I'm adding a 1, but I'm also subtracting a 1. But in this case, when I pull that 1 out, it's not just the 1 I'm pulling out, because this negative 1 is also being multiplied to negative 3 because it's inside that parentheses, which is why I write it in that parentheses first. So it's really bringing out a negative 3 times negative 1, which is going to make positive 3. So I have negative 3 x squared minus 2x plus 1. This becomes plus 3 plus 2. Now I can simplify. This factors into x minus 1 squared plus 5. And that's my vertex form. And here I'm finding the y-intercepts, so when we find the y-intercepts, we plug 0 in for x. Well, that's just going to make those first two 0, so my y-intercept here is going to be negative 5. 0, negative 5. And here when I plug 0 in for x, 0 minus 2 is negative 2 squared plus 5, so it's going to be positive 4 plus 5 is 9. And here, plug 0 in for x, I get negative 5 times positive 2, and that's going to be negative 10. And here, write in vertex form by completing the square. One example for you to try. And if you have any questions, make sure you ask me during tutoring or class.